Okay, when we're talking about renewable and non-renewable resources, the key here is that it all comes down to time. Renewable resources can be renewed in your generation, in your lifetime. Non-renewable take a much longer period of time. So if we think about a real simple one, like if we take a tree, you can cut down a tree, you can use it for firewood, you can plant a new tree, and it'll grow back in your lifetime that you can do the same process again. So most plants are going to be renewable because they can grow back in time and they work that way. Non-renewable resources would be things like coal. Now you can take coal and you can burn it, you can use it that way, but it takes millions of years for it to replenish or to replace itself. So you can't do this in a lifetime. That's why we consider it non-renewable. Now, other examples of renewable resources are things that are inexhaustible, which means they'll last forever. Things like the sun and the wind, things of that nature. Those are going to be considered renewable resources because we have an endless supply of those things. When the sun burns out, we're done, so it doesn't make a difference. When the wind stops blowing, that won't happen until the sun dies off. So it's kind of, they'll always be there for us. Other examples of non-renewable might be things like nuclear fuels. Okay, we can run out of the supplies that we have. We can't just make more that way. So remember, it's time. If we can replenish it, it's renewable. If we can't, then it's non-renewable. Okay, let's take a quick look at fossil fuels. Obviously, from the name implies, they're fuels that come from fossils, and fossils are remains of once living organisms. So one of the things I want you to realize that 90% of our energy in the United States comes from these fossil fuels, so we're heavily fossil fuel dependent. The biggest that we use for producing electricity is going to be coal. Coal starts off as plants like peat in a bog moss or something of that nature. You have these forces acting on it, burial pressure, so being layered underneath stuff, putting those layers on top of it, add pressure, add heat, because as it gets deeper inside of the earth, it heats up, and time. And you'll notice that this peat gets squeezed down into lignite, then into bituminous coal, and then anthracitic coal. So it takes millions of years to form this, and then we can collect it through mining and burn it and make electricity from it. Petroleum and natural gas form along the same lines. You take once living things that are going to settle to the bottom when they die. We'll notice that what we have is, as this goes on, these organisms are turned into natural gas. Same process. You're applying pressure, you're applying heat, you have time. We can get trapped natural gases and we can have trapped oils that way. One of the concerns with fossil fuels is that what happens when we run out? Well, we're exploring some other things. Currently, they're looking at tar sands and oil shale. Both of these are very messy, very environmentally polluting ways of collecting these petroleum products. So while now they'll fulfill the need, it might be time to start looking for things otherwise, because these are very unclean fuels for us to be using. Okay, so we've talked about fossil fuels, and those would be like a deposit that we would mine out and get things for. There's other ones as well. We have mineral reserves and mineral ores. Ores tend to be metals, reserves tend to be other minerals that we'll use, but reserves and ores are terms that we use when we're talking about having money. So that means that they're financially rewarding to mine these things out. There's enough of the material there that it pays for the cost of the mining, and you still can make a profit from them. Now, they form through these three: igneous process, hydrothermal processes, and placer deposits. What we're talking about is, if we talk gold, simply gold, what we'll notice is if you have this intrusion of magma into the system, it's going to be hot and it's going to cause things to melt. So if you can melt the gold down, then you have liquid gold. And as this recedes out, it's going to cool, and you'll have this gold that's melted and fall or flowed into these little cracks and crevices. And what will happen is, over time, they'll cool down, and that's how you can find those big veins of gold and things of that nature. Now, whether it's hot water or magma, that takes care of the first two. When we're talking placer deposits, what we're talking about is if that gold finds its way up to the surface and then starts getting broken off and eroded, it'll travel downriver. And as it goes downriver, it'll get placed, and that's what we're talking about here is placer deposits, where we're seeing this golden rivers and things of that nature. A lot of times, if they find the gold, what they'll do is they'll march upriver and keep looking for it, and hopefully they can find that big mother lode that they're looking for. Now, we've talked about fossil fuels, we've talked about some metals a little bit. The lesson will go into a little more detail. The last one are these non-metallic minerals. And these are the ones that we're going to collect for money. They have to find in the reserve so that we can find them and make a profit from them. Perhaps the most common ones we know of are gemstones. So if we're hunting out for diamonds or corundum or other gemstones like that, these would be mineral resources that we could make a profit off of. Building supplies, we have limestone, clay, quartz. Around here in Vegas, we have an awful lot of gypsum. So those are building materials that we can mine out and use those commercially. Salt, table salt is one. They actually mine it out. With the table salt, what you'll find is there'll be salt deposits down underneath. And they'll drill a hole here and they'll drill a hole here. They'll pump in water, dissolve the salt, make salt water, and then pump that out and then dry out the water, and that's how they get salt. And then also we can get some fertilizer materials such as potassium and sulfur as well. Okay, so that's it for this video. As always, good luck on the lessons, and we'll see you in the next video. To begin, we're going to take a look at making electricity. And most of the electricity we make in our country is done the same way. We basically start off down here with a turbine, which is basically some kind of thing that'll spin. It'll have these little blades that'll make it spin. And as it spins, it causes a generator to spin. And as that generator spins, it generates an electric current, and that's how we make our electricity in the country. So the big change is how we make this turbine spin is all. Now, solar is our most abundant source of energy. If we could harness the power of the sun, we could get all of the energy we need only from using solar energy. The problem with solar is the technology doesn't allow us to grasp all of it, and also it's kind of costly to put in. There's two main types of solar energy systems. We have passive and we have active. Passive means we're not doing anything, we're just letting it naturally happen. So if you can see in the picture here, in the wintertime, we'll have sunlight that'll come in through the windows, and that'll just passively heat the inside of the house. An active solar system actually takes and does something with the energy. It's actually forcing it to move. So here we can see a little pump here. And what we're going to do is we're going to take this water and we'll flow water up in through these solar panels and then store it here into a hot water tank for use in the house. So active means we're putting something into it. Passive means it's just kind of happening as it is. Now down here, you kind of see a new thing for us. And this is Solar One over in Barstow. And you've probably seen this on the drive from the 15 down to Los Angeles. But what you'll see is all of these little mirrors here take the sunlight and they reflect it up into this one tower. They'll run water up into that tower, and what that does is it causes it to boil and turn into steam. That steam they can then harness through pipes, run it across a turbine and cause that turbine to spin, thus turning a generator, thus making electricity. So it's a different kind of way of using the solar energy, and we're still able to produce electricity from it. Nuclear is another promising one because we can get a lot of energy from a small little set of nuclear material. If we notice here, we have our reactor, and what we're doing is we're able to put this down, and that generates heat. So the process of nuclear is we're capturing this heat, and this heat then we use to generate steam, and that steam goes, spins a turbine, spins a generator, and we make our electricity. So that's a nuclear power plant. The bad thing about nuclear power plants are they generate a lot of heat, so we need to have cooling areas to cool off the water and to cool off the steam so we can reuse it. We're also going to have the waste materials from the reaction, and that's something that we have to get rid of. And then there's always the threat of emergencies or dangers or accidents happening. In the lessons, they'll go through what some of the bigger accidents that we've had. Now, wind energy holds a lot of promise. They say if we could harness the wind energy in just North and South Dakota, we could accumulate enough electricity to supply 80% of our need as a country. Wind power is a little bit easier, as you can see. We have our turbine here, which is basically the rotor part here, and that's going to spin, and as that spins, we run it through a gearbox to speed it up a little bit, and that gets our generator going, and we're able to make a lot of electricity this way. Wind power has a lot of promise. You see a lot of it going up. It's just the technology isn't there yet to capture all of the electricity that we need, but it's getting there, and it looks like one of the more promising ones. Now, geothermal is all in its name. Geo is earth, thermal is heat. So what we're doing is we're gathering heat from the earth, and that will then heat up water, form it into steam. The steam then spins a turbine, like we said already, making a generator. We generate our electricity that way. We can then cool that steam back down into liquids and then put it back down, and we can kind of run this whole cycle going around this way if we can work it out. Geothermal is promising. The problem is there's not an awful lot of areas where it's very practical. We don't have a lot of geothermal activity throughout the entire country. In the areas where it is, it's a very promising source. Now, hydroelectric is one that we should be a little familiar with. Hydro is water, so this is going to be electricity coming from a hydroelectric dam, from a water dam. Basically, we dam up the river and we build this reservoir. So now we've gotten water up here. Then what we do is we collect the water and we allow it to fall. And as it falls, it picks up speed. And that speed then will then spin a little turbine, thus a generator, and we can produce our electricity this way. And this is what we see over at Hoover Dam, where we have the water coming in, it falls down over and spills into these turbines, causing them to spin, and that's how we make electricity. Now, hydroelectric works really well, but again, we've already tapped most of the rivers and most of the good sites that can be using this, so there's not a lot of expansion into hydroelectric anymore. And finally, we have energy from tidal fluctuations. And this is a little promising. It's a little bit difficult to do just because of a lot of construction and issues. But if we find a bay or an estuary, and what we're basically going to do is at high tide, we open it up and we allow water to flow into the bay. Then we keep it there, and at low tide, we open up a separate channel, which then allows the water to flow back out. And in this separate channel is where we're going to place our turbine, so it'll spin this way, thus spinning our generator and making our electricity. So it's promising. The problem is that we would need to take a bay here, and you would have to basically construct this dam to close it off. So while the inside's fine, you're limiting transports in and out of it. That would be where we would have the issues. Okay, well that's it for this video. I tried to be quick and just give you a quick overview. The lessons will explain all of this in a lot more detail, so good luck on the lessons, and we'll see you in the next video. Fresh water is probably one of our more important resources. We need it for life. It's really critical. We can't have life without access to fresh water. And only less than 1% of the Earth's water is going to be usable. So most of the water is going to be salt water tied up in the oceans. From that, we have some fresh water that's not really usable, and then we'll also have glaciers and ice caps and things of that nature. So we're talking a very small amount of Earth's water is going to be usable, and we need it for life. The big issue when it comes to water is water pollution, and there's two kinds of pollutions that we want to talk about, point and non-point source pollution. Point source pollutions are really easy to find. That's if we have a wastewater treatment plant that's flowing it into a river, if we have a factory with an outflow pipe that's flowing it in, or if we have some kind of a factory or something where we can find where it's coming from. When we know where, okay, it's coming from, that's a point source, and they're easy to fix, they're easy to correct. We can go back and say it's you here, it's there. Non-point are a little bit more difficult. Non-point source pollution is where we don't know where it's coming from. And a lot of times this is caused by what we call runoff, and that's where water runs over the surface after rains and things of that nature. So if we look in the streets, you have rain come down here, it pools in the streets. What does it do? It washes all of the stuff off of the streets and it comes down into the river that way. So we can't go back and find exactly where it's coming from. We kind of know, but it's not something that we can cure easily. The same would happen out in the country with farming in suburbs and things of that, is anytime you have water that can run over and pick up the pollutant and deposit it, that's going to be this non-point solution. Okay, so let's talk about the atmosphere. The atmosphere is critical because it provides us with the heat that we need to maintain life on the planet. It does this by what we call the greenhouse effect. So we have some of the energy from the sun that comes in, and much like in a greenhouse how it's trapped by the glass, on our planet it's trapped by these atmospheric gases. Now, water vapor is going to do most of it. We have an awful lot. That's what our humidity is, and clouds and things of that nature. But we also have this component here, this carbon dioxide. And the carbon dioxide is the one that's getting a lot of notoriety because since 1859 in the Industrial Revolution, we've been putting more and more carbon dioxide out there. Now we can think of this greenhouse effect as being like a series of blankets. And this one here shows us really nicely what we're talking about is by adding more and more to this carbon dioxide blanket. It's just like if we put more blankets on you, what would happen? You would get warm. And that's how we end up with this whole concept of global warming. We're talking about how we're making this carbon dioxide portion here larger, and in doing so, we're going to make the planet a little bit warmer. And what's going to happen when it gets warmer, we don't know. That's one of the things that makes it kind of scary. Now, the other thing we have to worry about with the atmosphere is that's where we breathe from. So in this cartoon down here, what I'm trying to show you is all of the ways that we are polluting the atmosphere with smog, with exhausts and things of that nature. The lessons will go into both of these concepts a little bit more in detail, but I just wanted you to see that these are the issues that we have to be aware of when it comes to the atmosphere. Finally, we get to land resources. Land resources, what we're talking about first and foremost is soil, and we'll talk about that in an upcoming unit. We have our forests that also consider here, and you can see that we're clear cutting them down. The problem with the clear cutting down is we're taking away everything. So now we have bare land, water comes down. We learned a little bit about runoff. It's going to take away some of that soil and things of that nature. We have fossil fuels and metals that we have in the land that we're mining away. And mining itself can be a very damaging practice. If you take a look here, you can see these large gaping holes just sculpted into the Earth's surface. So we're getting a little better with repairing these things, with replanting and filling in old mines and things of that nature. But still, we have to be aware that we do have these, and they're finite. They're not an unlimited amount of land resources. So that's it for our video. As always, good luck in your lessons, and we'll see you in the next video. Okay, so where did caring about the environment come from? Intuitively, we've probably always known it. We've always done some practices that would help it. But where did we start seeing legislation and governments caring about protecting the environment? The beginning that we mostly like to go back to is this one here that happened on June 22nd in 1969. At this point, there was an oil slick on the Cuyahoga River in Cleveland that caught fire. And it really brought to public light the idea that man could actually have an impact on the environment, and we kind of needed to be a little more careful and cautious with what we were doing. And that caused an awful lot of legislation to occur, and that's what we'll talk about here in the next slide. Now, from the lesson, I took them and put them in chronological order, so we'll kind of go through it that way. The first one in 1970 was the Clean Air Act, and that one established the National Ambient Air Quality Standards. So for 6 different things, they said this is how much we can tolerate. So they looked at carbon monoxide, ozone, lead, sulfur dioxide, nitrogen oxides, and particulates like dust. So in 1970, they passed legislation that said how much of this we can measure in the air would be acceptable and safe. In 1972, we had the Clean Water Act, and that one was where we went back and we started to eliminate point source pollution. So if we could find where companies and businesses were polluting, we would go back and say, okay, you need to stop this. We need to maintain clean water. This also caused an increase in the number of sewage treatment plants. Prior to this, raw sewage frequently was dumped into the rivers. Now they treated it before they were dumping it. In 1974, we had the Safe Drinking Water Act, and that, much like the Clean Air Act, set maximum contaminant levels in drinking water. So every year you'll get a little pamphlet from the water company that says how much stuff is in the water and whether or not it's safe. That's a product of the 1974 Safe Drinking Water Act. In 1976, we had the Resource Conservation and Recovery Act. And this is where they made it illegal and unsafe for the dumping of hazardous wastes. So companies were now not able to just get rid of stuff. Now there was legislation that you could go after the companies that were practicing these things. And finally, in the lessons that I'll mention, 1980, the Comprehensive Environmental Response, Compensation, and Liability Act, which created a Superfund. And this would allow them to clean up the abandoned sites. So the issues of the past, now there was money put aside to clean up those things. So if a company went out of business and just left, we now had money to go in and clean up the site. So all of this legislation gave us power to go back to companies, go back to the pollution sources and say that these are the things that need to be cleaned up. So what can you do as an individual? Well, the 3 R's: reduce, reuse, and recycle. Use less, buy less, avoid the waste, kind of cut your things down, cut your use down. That'll help a lot. Reuse things, use them more than once. So like if you buy a bottle of water, use the water bottle for an extended period of time. And then finally, recycle. If it's recyclable and able to be remanufactured into something new, go ahead and help out with that. Okay, well, that's the end of our video today. Good luck with your tests and quizzes, and we will see you in the next video.